Hello, checkpoint students. This is questions and exam sample paper, Cambridge Lower Secondary Sample Paper, Science Paper 2, Stage 8, Paper 2. Let's start with question number 3. We will answer only physics question in this paper. Okay, look at the diagram. It shows the addition of different colors of light. Okay. Be careful, don't mix between two important things, mixing colors and color filters. When you're mixing two colors, it produces another new color. So as in this question, when you add green plus red, you will gain the yellow. Okay, you will gain yellow color. And when we mix the blue and green, the color will be cyan. And when we mix the red and blue, you will get magenta. Okay, magenta or magenta as you prefer to pronounce, and I pronounce like magenta. Complete the diagram by writing the correct color in each box, so we complete the boxes. Question number B, Lily investigates two filters. Look at the diagram. Okay, here we have white light, the white light incident on a red filter. So let's revise what will happen when the white light incident on a red filter. So the red filter will absorb all other frequencies and reflect only the red color. So the color gets out from the red filter, it will be the red one. Again, when the red filter, when the red color or red light incident again on a green filter, so green with red, what will happen? What do you predict? Green only reflect the green color and absorb all other frequencies. So on the screen will receive no light. So the answer here will be no light. Question number 6. This question is asking about magnetic field and to practice how to draw the magnetic field line. Be careful, you must practice more than one time how to draw the magnetic field lines for attraction and repulsion in both cases. The north pole of one bar magnet attracts the south pole of another bar magnet. Look at the diagram. It shows two bar magnets. Draw only two magnetic field lines between the magnets. Include the arrows. Okay, how can we draw it? Just like this, you must connect because this is attraction between the north and south pole. It will be attracting. So, as he asking in the question, just to draw two lines only, and don't forget to draw the arrows. The magnetic field lines always aligns from the north pole to the south pole. Okay. Question number B. The north pole of one bar magnet repels the north pole of another bar magnet. In the first part, the north pole of one bar magnet attracts the south pole. So this is attraction force between the two magnets. While in repulsion force, when you approach two like poles, because the like poles will repel each other, while the unlike poles will attract each other. Okay, how can we draw the magnetic field lines if there is two similar poles near to each other. Look at the diagram. It shows two bar magnets. Draw two magnetic field lines between the two magnets. Okay, you must know when two like poles get near each other, so it will repel each other. So the magnetic field doesn't attract to each other. Okay, it's a simple question. Just you need to practice more than one time how to draw the magnetic field line for the attraction and the repulsion. We can make sure from the answer from the mark scheme. Okay, here we have the mark scheme in a drawing. Okay, just like this, just draw lines between both of them. You can draw more than one, and you can draw only two. Okay, the first question about the color here, green and red is yellow, and blue and green is cyan, and in the color filter, the color is no light. Let's go to question number 7, which is asking about the solar system, Earth and beyond. The Milky Way contains a large number of stars and other matter. The diagram shows what the Milky Way looks like from outer space. Okay, Milky Way is our galaxy, and the collection of a large number or a huge number of stars that collect together is called a galaxy. So what is the name given to a large number of stars such as a Milky Way? It's called galaxy. It's called galaxy. Okay. And question number B, the Milky Way contains the stars and the planets. Name one other type of matter found in the Milky Way. What other type of matter that is found in Milky Way as stars? Stellar or stars is had another material that is found inside Milky Way, which is dust and rocks. Dust and gases. Okay, you can check the answer from the mark scheme, but after we finish the part C. The sun is a star in the Milky Way. What name is given to the sun and its orbiting planet? Of course, it is the solar system. Okay, let's check the answer from the mark scheme. Okay, this is question number 7. This is question number 7. Okay, the first one is galaxy, and 7B is dust or gas, and finally the answer is solar system. Okay, there is another 2 questions for physics in this exam. Okay, question number 9. He asking about the principle of moment. Mike and Oliver are on a seesaw. Okay, a seesaw is a common example that describe the principle of moment and the idea of moment. The moment, to remember, it is the relation between the force and distance. Okay, the moment is equal L force times, you must know, times L perpendicular distance. The distance must be perpendicular to the pivot or the fulcrum. Okay. Okay. L force times L distance. L force times L distance. Okay. Type. The seesaw is balanced. Okay, this is very important in the question. When he tells you in the question, the seesaw is balanced, so you have the green cards to use the principle idea of moment. What does that mean? When the seesaw or any system is balanced, that means the total moment clockwise is equal to the total moment anti-clockwise. Okay. Oliver exert a moment. This is the pivot. And when Oliver sat on the seesaw, he exert a moment, and his moment is acting downward with a clockwise direction, while Mike is exert a moment that acts anti-clockwise direction. When the seesaw is balanced, that means in the total moment, clockwise must equal the total moment anti-clockwise, okay? I'm just using a symbol to save our time. Just, you cannot write this like this symbol. You must write it with a complete word, like total moment clockwise must equal total moment anti-clockwise. Or you can say instead, the net moment equals 0, or the net force equals 0. That means the system is balanced. Okay, let's complete the question. Mike has a weight. Where is Mike? Mike is Mike. This is Mike. Okay. Mike has weight 400 Newton, and his distance away from the pivot is 3 meters. While Oliver, we don't have weight of Oliver, but we have only the distance away from a pivot, which is 2 meters. Okay. What the question here? The question is asking to calculate Oliver weight. Okay. So he asking about Oliver weight. Weight is acting always downward. To use the principle of moment, so the total moment, the moment of Oliver, which is equal the force of Oliver, which is in this case is the weight, which is in this case is the weight of Oliver, for Oliver times 2 meters must equal the moment of Mike, which is a 400 times the 3 meters. Okay, don't write the unit in the question. Okay, so this is for Oliver, and this is for Mike. Okay, this is for Mike. To calculate the weight of Oliver, so you can complete the equation 400 times 3 divided by 2. So the weight here is equal, okay, is equal 400 times 3. Okay, just a minute, we can contain it from a mark scheme. Okay, this is equal 1. Okay, this is equal 1, 2, 0, 0 divide 2, which is equal 600 Newton. Okay, تمام. Again, ممكن نعملها تاني to understand very well. Okay, you have the weight of Mike and you don't have the weight of Oliver. So by applying the principle of momentum, okay, the weight times 2 is equal 1,200. So the weight of Oliver equal 1,200 divided by 2, which is equal 600 Newton. And the unit is given in the example, so there is no need to write the unit. Question number D, in the same question, asking about the pressure. Pierre and Rajiv stand upright. Okay, Rajiv and Pierre stand on their foot. look at the table. It shows some information about Pierre and Rajif. Rajif or Rajif, whatever, okay. Pierre, his weight is equal 440 in Newton. Okay, this is a force. And the area of its shoes in meter square for Pierre is equal 0.04. While Rajif has a weight equal 500 in Newton, and his area of his shoes is equal 0.05. Pierre exerts a greater pressure on the ground. Pierre, as you see in the question, exert a greater pressure on the ground, okay? Use calculation to explain why Pierre exert a greater pressure on the ground of Rajif. Okay, let's complete. Sorry. To make sure this sentence is correct, you must make a calculation, calculate the pressure for Pierre and calculate the pressure of Rajif. Okay, let's start with the pressure of mean of Pierre. The pressure of mean of Pierre is equal to force divided by area. Okay, what are the force of Pierre is equal 440 divided by area equal 0.04. Okay, which is equal 1,100 Newton per meter square. While the pressure of Rajif is equal the same rule, force over area equal 500 divided by 0.05. It will equal 10,000 Newton per meter square. So by using a calculation, we can prove that the Pierre is exert greater pressure, okay? And without calculation, you must notice that as the area of shoes decrease, as the pressure increase, as we say in the result, and as the area of the shoes increases, so the exerted force will increase, which means exert more pressure. This is a question for physics paper, stage 8, paper 2, sample test 2020. Thank you for watching, and please like and subscribe my channel to continue. Thank you.